Hi friends, I am Balaji Rao. Welcome to BR Max class. In this class, we are going to learn about types of partial fractions we have in integration chapter. This is important class to understand coming classes. This is continuation of last class. In last class, we learn the definition of proper function, improper function and types of partial fraction. In this class, we will learn how to convert given rational function into partial fractions. Here I divided these problems into 4 types. You see, these are type 1 problems. And here you can observe these are the rational functions. You can observe all these rational functions. Here 2 conditions are satisfied by all these rational functions. What are those 2 conditions? First condition, degree of numerator is less than degree of denominator. You observe this is a rational function because it is of the form f of x by g of x. It is also rational function because it is of the form f of x by g of. Degree of numerator is less than degree of denominator, then that rational function is called proper function. Here 1 can be written as x power 0. That means degree of numerator is 0. What about degree of denominator? Degree of denominator is 2. So degree of numerator is less than degree of denominator. First condition satisfied or not? Yes, satisfied. So it is a proper function and denominator contains non-repeated linear factors. In previous class also we discussed denominator contains non-repeated linear factors. What are non-repeated linear factors? You observe x minus 2 is a linear factor because whose degree is 1, x minus 2 degree is 1 and x minus 2 is not repeated anywhere in the denominator. So x minus 2 is a linear factor. Moreover, it is a non-repeated linear factor. X minus 3 is also linear factor because its degree is 1 and it is not repeated anywhere. So here whenever you observe a rational function of this type means which type? Degree of numerator is less than degree of denominator and denominator contains non-repeated linear factors. Then how we convert this into partial fractions? This is the procedure. If we write this rational function like this, then you will get the answer very easily. I'll write it as a divided by x minus 2 plus b divided by x minus 3. Further, I'll proceed in the values of a and b. It is important. You must know this rational function satisfies these 2 conditions. That's why we should write it into partial fractions like this. Okay. You see this one. This is a rational function because it is of the form f of x by g of x. Degree of numerator is less than degree of denominator. Yes, degree of numerator is 1. Degree of denominator is 2. So first condition satisfied. Denominator contains non-repeated linear factors. Yes, x plus 1 is a linear factor. Is it repeated anywhere? No. So denominator contains non-repeated linear factor. X plus 2 is a linear factor. Is it repeated anywhere? No. So x plus 2 is a non-repeated linear factors. So this problem comes under type 1. You need to identify that. Okay. Then how we write this as? We write this as a divided by x plus 1 plus b divided by x plus 2. Here no compulsion that a divided by x plus 1 only. You can write like this also. A divided by x plus 2 plus b divided by x plus 1 also you can write. But generally we will follow this procedure a divided by x plus 1 plus b divided by x plus 2 to avoid the confusion. You see this third one. Is it a rational function? Yes, because it is of the form f of x by g of x. It satisfies the first condition. Degree of numerator is less than degree of denominator. Yes, degree of numerator is 1. What is degree of denominator? If you multiply all these things, degree of denominator is 3. So here first condition is satisfied. Denominator contains non-repeated linear factors. Yes. So how we write this into partial fractions? We write like this. A divided by x minus 1 plus b divided by x minus 2 plus c divided by x minus 3. We write like this and we will simplify further to get the values of a, b, c values. You see this one. Degree of numerator is 1. What is degree of denominator? Degree of denominator is 2. That means it satisfies first condition. Degree of numerator is less than degree of denominator. Yes. Denominator contains non-repeated linear factors. Yes. 2x plus 3. Its degree is 1. It is a it is a linear factor. Is it repeated anywhere in the denominator? No. X minus 5 you see, is it a linear factor? Yes. Is it repeated anywhere in the denominator? No. So what we say here, denominator contains non-repeated linear factors and degree of numerator is less than degree of denominator. In this case, how we write this rational function into partial fractions? A divided by 2x plus 3 plus b divided by x minus 5. Now, type 2 partial fraction. You observe here, degree of numerator is less than degree of denominator. It is also proper function only. What is proper function? We learned in last class. Degree of numerator is less than degree of denominator, because you see here, degree of numerator is 1. If you simplify this denominator part, degree of denominator is 3, because when you expand here, x square term will be there, here x term is there. When you multiply these things, degree of denominator is 3. So here first condition is satisfied. Second condition you observe here, denominator contains repeated linear factors. Repeated linear factors. You observe here first condition is satisfied. You observe the second one. X plus 1 is a linear factor because its degree is 1. Here x plus 1 whole square is there. X plus 1 whole square means x plus 1 into x plus 1. It tells you that denominator contains repeated linear factor, and you see x plus 3 is there. X plus 3 is non-repeated linear factor. However, we consider this as a denominator contains repeated linear factor. When denominator contains repeated linear factors, how we write this rational function into partial fraction? You must know how to write this rational function into partial fractions. We will write like this: a divided by x plus 1 plus b divided by x plus 1 whole square. Please try to understand. In this way, if we simplify, we are going to get the things very easily. See, x plus 1 whole square is there. Now for this, I written a divided by x plus 1 plus b divided by x plus 1 whole square. And another non-repeated linear factor is there. For that, we will write c divided by x plus 3. Once, if we write this rational function into like this, then we will simplify this further to find the values of a, b, c. Okay, you see this one, degree of numerator is what? 1. Degree of denominator is what? 3. Here x plus 1 is non-repeated linear factor because its degree is 1, it is not repeated anywhere. What do you say about x plus 2 whole square? It is a linear factor. Here whole square means x plus 2 into x plus 2. That means x plus 2 is a repeated linear factor here. So in such case, how we write this? We write like this: a divided by x plus 1. For x plus 1, I written like this. For x plus 2 whole square, how we will write? For x plus 2 whole square, we will write like this: b divided by x plus 2 plus c divided by x plus 2 whole square. This is the procedure to simplify to split a rational function into partial fractions. I hope you are understanding. Now you see the third example, degree of numerator is 1, degree of denominator is 2. That means here first condition is satisfied. Second condition, denominator contains repeated linear factors. Yes, x plus 2 is a linear factor. It is repeatedly, it is there. X plus 2 whole square is there. In this case, how we write this as? We write this as a divided by x plus 2 plus b divided by x plus 2 whole square. We will simplify this further to get the values of a and b, and then we will proceed. It is important, after seeing the rational function, you need to identify it comes under type 2. Degree of numerator is less than degree of denominator, and denominator contains repeated linear factors. See here, type 3 first point, degree of numerator is less than degree of denominator. Type 1, type 2, type 3, first statement is same, because in type 1, type 2, type 3, we are discussing about proper functions only. What is proper function? Degree of numerator is less than degree of denominator. You observe here, degree of numerator is 1. What is degree of denominator? When we multiply these two things, you will get a degree of denominator is 3. Okay, so here first point is okay. Denominator contains irreducible quadratic factors. What is irreducible quadratic factor? For example, you see something like this, x square minus 1 is there. We can reduce into linear factors like this, x plus 1 into x minus 1. We can reduce into linear fact. What about x square plus 1? Can we reduce it into linear factors? Can we reduce further into linear factors? No, because there is no real roots for this equation. X square plus 1 is irreducible quadratic factor. X square plus 4, yes, it is a irreducible quadratic factor. X square plus x plus 1, it is a irreducible quadratic factors. These are the examples for irreducible quadratic factors. What is this type here? Denominator contains irreducible quadratic factors. When the denominator contains irreducible quadratic factors, then how we write these rational functions into partial fractions? That is all about type 3. You see here denominator contains irreducible quadratic factor. No? So what to write? In what way we need to write? We will write like this: ax plus b divided by x square plus 1 plus c divided by x minus 1. You should remember these things, how we write this rational function into partial fractions when denominator contains irreducible quadratic factor. We write like this and we will simplify further to get the values of a, b, c. You observe here, degree of numerator is, here 1 is there. 1 can be written as x power 0. Degree of numerator is 0. Degree of denominator is 3. So first condition is satisfied. Second one, denominator contains irreducible quadratic factors. Yes. You see here x square plus 2 is there. X square plus 2 is what? Irreducible quadratic factor. Here x is non-repeated linear factor. So how we write this as? We write this as a divided by x plus, for this x square plus 2 irreducible quadratic factor, we will write like this, as a is already over, bx plus c divided by x square plus. Now you see this third example. First condition satisfied or not? Degree of numerator is 1. What about degree of denominator? When we multiply these two things, we will get that degree of denominator is 4. So degree of numerator is less than degree of denominator. Yes, correct. Denominator contains irreducible quadratic factors. You see here x square plus 1 is a irreducible quadratic factor. Yes, x square plus 3 is also irreducible quadratic factor. In such case, how we write this? For every irreducible quadratic factor, we will write expression of this form: ax plus b. Ax plus b divided by x square plus 1. As a and b already we used, for this x square plus 3, we use cx plus d. Cx plus d divided by x square plus 3. Right? Now, last type of rational function, we will come to know how to split it into partial fractions. How to split it into partial fractions. Type 4. Here you can observe that only one condition is there. Degree of numerator is greater than or equal to degree of denominator. You observe here, degree of numerator is 3. Yes, degree of denominator is 2. That means here degree of numerator is greater than degree of denominator. So what type of function it is? It is an improper function. It is a rational function. Moreover, it is an improper function because degree of numerator is greater than degree of denominator. In such a case, what we do? We divide numerator by denominator. When you identify it is an improper function, we divide numerator by denominator. When we divide numerator by denominator, then we will be in a position to write it into proper function. What is proper function? Proper function means degree of numerator is less than degree of denominator. Once if you are able to write this improper function into proper function, then it comes under any one of these types, type 1 or type 2 or type 3, then we will proceed further. Try to understand, whenever you identify an improper function, first we will convert into proper function. How to convert improper function into proper function? You just divide this numerator by denominator. When you convert this improper function into proper function, then we can identify that this comes under type 1 or type 2 or type 3. Then we proceed further. You see this problem, degree of numerator is 4. What is degree of denominator? Degree of denominator is also 4. Here degree of numerator is equal to, you observe here, degree of numerator is equal to degree of denominator. Is it is a improper function or not? Yes, it is a improper function. When you identify that given rational function is a improper function, then we divide numerator by denominator and we will write it into proper function, and then we will proceed as per type 1 or type 2 or type 3. Actually, there are 4 types of rational functions. By seeing those rational functions, you need to identify this comes under which type. In coming classes, we are going to discuss all the problems type wise so that you will feel that this integration by partial fractions is very easy.